Energy Literacy, the Daily Energy Unit D, by Bruce Logan, Penn State University. If we want to communicate, we need to speak the same language. How can we do that? Well, we translate it into something we know, into one common language. If we want to communicate when it comes to energy, how do we do that? We translate it into something that we know. Something we all know is that we need about 2,000 calories a day to live. That's something we can relate to. But how do we relate that to other things that either consume energy or produce energy in our lives? Well, for example, if I were to take that 2,000 calories a day that I eat and use that energy to power 100-watt light bulbs, how many could I power? 3, 4, 5, 10? Actually, the answer is just one light bulb. A single light bulb running continuously consumes the equivalent of about 2,000 calories a day. Now, if you look at all the things that we encounter in our lives in terms of energy units, so many of them have different units. For example, 2,000 calories with a capital C is really 2,000 kilocalories. Daily food for a horse is 20,000 kilocalories. The energy in a gallon of gasoline, 114,000 BTUs or British thermal units. Or maybe you look at the engine in your car and it's 120 horsepower. How can we understand these units? Well, one way is we could put them all on the basis of a kilowatt hour. However, look at those numbers. They're all still rather confusing, and it's tough to relate to a kilowatt hour. So we need to find something that's not quite so confusing. I propose that we define 2,000 calories a day, or the food that one person eats, as the unit 1D, one daily energy unit. If we use that unit, we could say, well, our home uses 13D, or while we eat 1D, a horse needs to eat 10D. The energy in a gallon of gasoline is about 14D. So this common unit of D allows us to now compare all these things in terms of something that we know. That is, how much food we need to stay alive. And that unit of 1D is the same to everybody on the planet. Some people need a little bit more, some people need a little bit less, but the general concept of the food we eat every day can help define what energy consumption is like. So when you look at things now, for example, you can see the electricity that we consume per capita, not necessarily just in your home, but averaged across all people in the US, is about 40D, and all energy normalized per person in the US is about 104D. That makes this unit of D very nice because it ranges for the food and other activities up to about a maximum of about 100. Look at your car, which say gets 18 miles per gallon and you're commuting 18 miles. Your commute costs you about 14D, 1 gallon of gas. If you were to travel in a more fuel-efficient car, say a Toyota Prius or something like that, that commute might only take 4.9D because you would use less gasoline. Or what if you used an electric car? Well, to charge that car and use the energy in that battery, it's about 27 kilowatt hours to go 100 miles, or 2.1D. Let's say that you want to put solar panels on your house. Well, each solar panel produces 0.43D. That means averaged over the day and with typical sunlight in, for example, Pennsylvania, you would achieve about 0.43D of energy capture out of each one of those panels. So if your house uses 13D, well, you need about 30 solar panels. If your car is an electric car and it uses 2.1D, well, then your commute needs about 2.1D, or about 5 or 6 solar panels. How much energy should we use? Well, there's a study done by ETH Zurich which suggests a 2,000 watt society. 2,000 watts is about 20D. Currently, Switzerland has the average population having about 53D, which is about half of what we consume in the US, which is about 104D. So if we're going to have to try and reduce our energy consumption, that's going to have to go down quite a lot. Going forward, how can we do that? Well, can you reduce the energy for your commute? Can you save more energy at home? Or energy, say, for transport or food? Or put a solar panels on your house and reduce your consumed D. So the question really is, going forward, how can we make that 20D green? Thanks for listening, and I hope that you find a way to use D in your life to understand the energy you consume.